Right now, sitting in a lab somewhere on Earth, there's a piece of technology faster, smarter, and more capable than anything we've ever launched into deep space. Not a spacecraft, not a rocket. Something quieter. A prototype, a material, an algorithm that could outperform machines we've spent 50 years building. And here's the part that should genuinely unsettle you. If we launched a spacecraft toward another star system today, using our absolute best rockets, our most advanced engines, something built decades later right here on Earth could catch up to it, pass it, beat it there. We like to imagine space exploration as a race against the universe. But what if the real race is against ourselves? What if we're already outrunning our own machines? And almost nobody is talking about it. Here's the strange part. This isn't speculation, it's basic math. And it's been quietly reshaping how space agencies plan missions for decades. Picture two spacecraft. Ship A launches today, cruising at a respectable speed toward a distant target. Let's say a nearby star system, thousands of years away at current speeds. Ship B launches 20 years from now. It's not radically different in design, but thanks to 2 decades of propulsion advances, it's dramatically faster. Maybe just 10% faster in raw velocity. That sounds small. It isn't, because speed compounds over distance. A modest percentage increase in velocity, sustained across a journey of light years, doesn't just shave a little time off the trip. It can erase decades, even centuries, off the arrival date. Ship B, despite launching 2 decades later, can blow right past Ship A somewhere out in the void, arriving at the destination first. Ship A becomes a monument, a relic still flying permanently in second place. This isn't just theory. We've already lived through a version of it. In the 1970s, Voyager 1 and 2 launched using the fastest, most advanced propulsion humanity had ever built. State of the art. Cutting edge for its era, engineered by some of the brightest minds in aerospace history. But less than 50 years later, engineers were already sketching concepts that could outpace it if launched today. Ion propulsion systems that sip fuel for years of continuous thrust, gravity assist trajectories that use planets like slingshots, even early solar sail prototypes that accelerate using nothing but sunlight and starlight pressure. None of these existed when Voyager left Earth. All of them exist now. So here's the uncomfortable question scientists have had to face, mission after mission. If you're planning a project that will take 200, 500, even 1,000 years to reach its destination, why launch now? Why not wait? Wait for better engines. Wait for lighter materials. Wait for propulsion breakthroughs that haven't been invented yet. But given the pace of progress, almost certainly will be within a generation or two, it's a paradox with a name, the incentive to wait. And it means some of the most ambitious interstellar mission concepts ever drawn up on a whiteboard may never actually launch. Not because they're impossible, but because launching later is, mathematically, the smarter move. The rocket, sitting fully funded and ready on the launch pad, might be less valuable in the long run than the one still being designed. Which raises something even stranger, something bigger than any single mission. If waiting is often the winning move for spacecraft, what if Earth itself, its research labs, its engineers, its accelerating pace of invention, is already playing that game without fully realizing it? What if human progress on the ground is quietly, invisibly outpacing everything we've ever sent into the sky? That's not just a thought experiment. That's happening right now in labs you've probably never heard of. So let's follow that thread all the way down. If Earth's technology keeps accelerating faster than our spacecraft can travel, what does that actually mean for the missions already out there, flying through the dark right now? Take Pioneer and Voyager. When they launched, they carried the absolute best sensors, computers, and cameras humanity could build. The pride of an entire generation of engineers. Today, an ordinary smartphone sitting in someone's pocket has more processing power than the entire guidance computer that flew Voyager past Jupiter and Saturn. That's not a knock on the brilliant people who built it. Quite the opposite. It's a snapshot of just how fast the ground beneath our feet keeps shifting, while the machines we've already launched fly on, frozen in the technology of their launch year, unable to upgrade, unable to catch up. Now scale that forward, decades and centuries at a time. Imagine a probe launched today, engineered to reach a nearby star system in roughly 300 years. By the time it's even a tenth of the way there, the computers, materials, and propulsion systems being developed back on Earth could render its onboard technology, its cameras, its sensors, its entire mission architecture, almost primitive by comparison. The ship keeps flying, patient and unaware, but the world that built it keeps evolving faster than the ship can ever travel. This is exactly why some scientists now argue that the smartest interstellar strategy isn't to rush a launch. It's to invest in Earth first. Every year spent improving propulsion, material science, and computing here at home could shrink the eventual travel time so dramatically that patience becomes the real superpower, not the rocket sitting on the pad. The lab quietly working through the night, unnoticed, unglamorous, but decisive. And this isn't just abstract theorizing. It echoes something we've already lived through, right here on our own planet in our own history. Explorers who set out on foot centuries ago, mapping coastlines step by step, were eventually overtaken by explorers using sailing ships. Sailing ships were overtaken by steam engines by airplanes by satellites, covering the same ground in minutes instead of months. Earth's entire history of exploration has always rewarded the ones who waited for better tools, not necessarily the ones who left first with what they had. Which brings us to the real twist, the one that reframes everything we thought we knew about the space race. If this pattern holds, if Earth's own progress can genuinely outrun the very machines we send into space, then the question isn't really, when should we launch, anymore. It's something much bigger. Is Earth, right now in this very decade, quietly building the technology that will make true interstellar travel possible sooner than anyone currently expects? Because if the pattern from Voyager to your smartphone tells us anything, the answer might already be closer than we think, closer than most scientists are willing to publicly admit. Here's where it stops being theory and becomes something you can actually see happening. This isn't just a thought experiment anymore. It's unfolding in real research labs right now in 2026. Take propulsion. For decades, chemical rockets were the only serious option on the table. Slow, fuel-hungry, capped hard by basic physics no amount of funding could overcome. But in just the last few years, concepts like nuclear thermal propulsion, directed energy sails pushed by ground-based lasers, and early fusion-based drive concepts have moved out of science fiction pitch decks and into funded peer-reviewed research programs. Each of these breakthroughs doesn't just add a little speed at the margins. It can cut travel time to the outer solar system, or even to nearby star systems, by staggering almost unbelievable margins. Take materials science. Engineers today are developing materials that are simultaneously lighter, stronger, and more heat-resistant than anything available even 10 years ago. Materials that make faster, lighter, more resilient spacecraft not just theoretically possible, but practically achievable within a single career's time span. A hull that once needed to be thick and heavy for protection can now be thin, light, and just as durable, freeing up mass for speed instead of armor. Take computing and artificial intelligence. Systems being developed on Earth right now can already process navigation data, detect hazards, and make split-second decisions faster and more reliably than any onboard computer ever flown. A probe launched with today's AI could react, adapt, and navigate autonomously through unknown environments in ways the engineers who built Voyager in the 1970s couldn't have even dreamed of. They were still programming with punch cards and hand-calculated trajectories. Now put those three threads together: propulsion, materials, computing, and a striking, almost humbling picture emerges. Earth isn't just preparing to explore space someday. Earth is, in a very real and measurable sense, already outperforming the ships we've sent to explore it. The rate of improvement happening quietly in laboratories and research centers scattered across this one planet is now moving faster than the rate at which our spacecraft can physically travel through the void. This is the core truth hiding inside the incentive to wait paradox, the thing that changes how you should think about the entire space program. The greatest spacecraft humanity will ever build hasn't launched yet, because it's still being built quietly, piece by piece, in the minds and labs of ordinary people working on Earth today. Every propulsion patent filed this year, every new material tested in a university lab, every AI model trained on a server somewhere, is, in a strange and very literal sense, a faster ship than any of the ones currently in flight. So when we ask that old, frustrated question, why haven't we reached the stars yet? The honest answer isn't that we're too slow or that the universe is simply too big for us. It's that we're still accelerating. We're still in the wind-up, and the moment we finally do launch that first true interstellar mission, it won't feel like a desperate leap into the unknown. It will feel like the natural, almost inevitable result of Earth having already, invisibly, won the race against its own machines, one quiet breakthrough at a time. We're not behind. We're winding up. So let's go back to where we started. That unsettling idea that something built decades from now could outrun a ship we launched today isn't a flaw in our plans, and it isn't a reason for despair. It's a signpost. It's proof that human progress doesn't move in a straight line. It compounds. It accelerates quietly in 1,000 labs at once. And every single year we spend refining propulsion, materials, and intelligence here on Earth is a year that shortens the distance to everywhere else in the universe. Voyager didn't fail by being caught up to in raw capability. It succeeded fully and completely by being the first step in a staircase that's still being built, one where each new step covers more ground than the last, faster than the one before it. The probes of the future won't just be faster machines. They'll be the direct compounding result of everything Earth is learning, testing, failing at, and rebuilding right now, in this decade, while most of the world isn't even watching, distracted by everything else competing for its attention. So maybe the real headline isn't, "We haven't reached the stars yet, and maybe we never will." Maybe it's something far more hopeful. Earth itself is the most advanced spacecraft we currently have. It's just the one none of us think to look at, because we're standing on it, living our ordinary lives on top of the very engine that will eventually carry us outward. Every engineer refining a rocket nozzle, every scientist testing a new alloy, every programmer training a smarter navigation system, they're not just building tools for some future mission. They are the mission, already underway, already accelerating. And the next time you look up at the night sky, wondering when humanity will finally reach another star, remember this. The answer isn't out there yet, waiting to be found. It's still being built, right here beneath your feet, one quiet breakthrough at a time. If this changed the way you think about our place in the race to the stars, you're exactly who this channel is built for. Every week, Nebulix digs into the ideas that sit just outside the headlines, the quiet breakthroughs, the strange paradoxes, the questions most people never think to ask about space, time, and where we're really headed. So subscribe and let us know in the comments. Do you think humanity should launch now with what we have, or wait for something better? Either way, one thing is certain. The next great leap might already be closer than we realize,